So hello, welcome back. In the previous video, we were discussing about the general organization of SuperCollider as a software environment. In this video, we will discuss on a very specific issue, and starting from the diagram that we have discussed in the previous video, this one, we will focus on a specific aspect that needs to be, in my opinion, discussed first. So, to sum up what we have seen, the point is that we have a software component, the editor, in which we write things, and that gives us a feedback on the interaction with the software. We write code, then the interpreter executes, run the code, and if this code requires sound generation, then the request is sent to the server. Now, the first thing that with which many tutorials starts is to give you some examples of sound synthesis and sound generation. This is really cool, of course, and typically it is something that pleases the new user. Actually, I have a different perspective on introducing a SuperCollider, in some sense more abstract, a little bit more philosophical, maybe a little bit difficult, at least in the beginning, because I think that in order to use SuperCollider, the first thing that you have to understand, apart from the larger picture that we have already discussed, is the language itself. So, in this video and in the next one, we will focus on the language side of SuperCollider, that is on this block 3+2, and in particular, in this video, I'd like to discuss some very general aspects of the SuperCollider language. So we will not make sound. Is this a sad moment for you? I guess so. I'm sorry for this, but I think that this is something that will help us working better with sound generation later. So I'm sorry for the light condition of my studio. I've tried to cope with it, but I've not been really successful. So there are some lights reflecting on my shirts and my face and so on. But this is something that should not impede our work together. So the SuperCollider language, that is SuperCollider as a language. So the language is our interface to work with SuperCollider, the way in which we are able to work with SuperCollider. The language is an interface. Well, isn't this a sort of general statement about languages, natural languages in general? Well, natural languages such as Italian or English, German, French, Chinese, and whatever, can be thought as an interface for communication, something standing in between a speaker and a listener. And this interface can be, of course, very different from one language to another one. So the point is that a language a computer language is just like a natural language, if you want, but that is used to speak with a non-human agent, and in particular with a computing agent. Now, the interesting point is that even if the listener, in our case, is not human, this does not force us to rely specifically on a certain language. I mean, during the 60 years of development of computer languages, many thousands of languages have been invented mostly from scratch. Well, this is a very interesting point that raises some interesting issues in relation to semiotic aspects. And the point is that if there are so many computer languages, this means that there are many possibilities to build computer languages. And in fact, computer languages can vary a lot from one to another one. So, suppose you write a computer language. Point is, how do you create this artificial language? Now, in some sense, the same thing happens also for natural languages. Natural languages can be very different one from each other. And of course, we know that they can be, as an example, grouped in relation to their history, like Italian and French and Spanish or Portuguese. They all comes in some sense directly from Latin. They are Neo-Latin languages, while, let's say, German and English are generically Anglo-Saxon. And of course, there are various other languages that have been developed during 200,000 years of humanity. So, a possibility of thinking about languages is, of course, historically in terms of their development, historical development, but another possibility is to classify these languages in relation to their internal organization, that is, to create a typology of languages in relation to all their specific features. The same kind of possibility applies to computer languages. So, what happens is that computer languages can be grouped in different families following different paradigms. A typical, very basic distinction refers to imperative languages, functional languages, and object-oriented languages. Now, this typology can be made more complex. We are not interested into it in our discussion, but the point is that the SuperCollider language has been invented from scratch by James McCartney with the idea of adhering to the object-oriented paradigm, and in particular having as reference a specific language which is known as, its name being, Smalltalk. But the SuperCollider language has also borrowed some features from other languages, such as C, the C language. Maybe you heard about it because it is the probably most important. It is the language in which operating systems are written, and Python, which is a very widespread, high-level language, abundantly used in the last 20 years. So, The point for us is that SuperCollider, in terms of typology, is an object-oriented language. What does this mean? Well, actually, object-oriented. So it is oriented, it focuses on the notion of object. So what is the point in object-oriented languages? Well, if you think about the problem of addressing a computer, you can speak to a computer giving it direct order. Do this, then do this other thing, then do this third thing. Well, this kind of attitude is typical of imperative languages. In object-oriented languages, the main point is that we consider as a target domain to speak which not directly the computer, but a sort of universe, an environment of available objects, and we give orders, commands, to specific objects. So just consider the room in which you are. Probably there are many, or maybe just consider a typical class. There are many chairs, there are many desks, there are probably in a class there are laptop computers, there are many students. So your reference word in that case would be made up of chairs, desks, human beings. Let's call them students because we're thinking about students mostly. We say laptop computers and so on. So the idea in object-oriented languages is that we have a reference universe made up of objects, and we give orders to these objects. So it's just like being like Mickey Mouse giving orders. If you remember Fantasia by Disney, giving order like a wizard to cups and brooms and whatever. So you are provided with a magic stick and you give order to the things. Hopefully things for us will be better than for Mickey Mouse, because we know that he had to face some specific problems in giving order to this object. They start behaving a bit too much erratically. Now, of course, our aim would be to be able to construct a sequence of orders that behave in a specific way that we can control. So we have a certain universe and populated by objects, and we give these objects orders. Point is, which kind of objects do we need? Well, let's say that now the sun is shining, you see. Maybe better in this way. Let's say that we want to work with sound. Well, of course, we need some objects dealing with sound generation. Or let's say we want to work with music. Well, as an example, music can be made up of melodies. What is a melody? Well, a melody, at least at its minimum, it's a sequence of pitches in time. So we need containers, object working as containers for this kind of data. Pitches, maybe duration. Let's say we want to read the content of a file. Well, actually, a file is something that should be expressed in our language in order to be able to address it. Or let's say we want to work with time. Maybe we need to describe a certain process that can be realized, that can work over time. So we need an object representing this process. This could be a little bit abstract, but suppose you want to read a file. So the main notion is that you go to the file, say, hey, file, do something for me. That is, load yourself into memory so that I can play you back. Or maybe you're working with a certain process, a certain melody, and so you say, hey, melody, please transpose yourself of a certain interval. Let's say 1 octave up, above, or below the octave you are placed now. Or suppose you have a certain organization of duration. You might want to say, hey, rhythm, please stretch yourself or compress yourself by a certain factor. So the point is that all the objects can be addressed in this way. So let's consider what is going on. Let's consider what is going on in SuperCollider with a specific object, like, let's say, array. So what is an array? Well, an array is a container, an ordered list of elements. Just go to a certain library. Suppose you have a paper archive of all the books, like those still in use, but of course typical of the pre-computer era, and you have to look to find a certain book. So you have many paper labels, and you just go and see, okay, this one. In which way do you browse this sequence of cards? Well, actually sequentially, and you know that a certain book stays in a certain position because of a specific way of ordering cards, which is the alphabet. So the point is that a certain archive is organized as an indexed sequence of objects. Now, if you want to translate into programming languages in general this kind of organization, a list of ordered objects or an ordered list of objects, you typically use a construct which is named array. Now, if you want to make an array in SuperCollider, you can use a construct like this. This is something representing an array. So you can say that a certain object named Z, you can use letters. Then we will discuss the way in which you assign these names. Let's say that we have an object like an object, its name being Z, and you want to assign to this name an object representing an ordered list of elements. Now, this kind of this statement, this expression in SuperCollider, as we said, we speak about expression. This expression, Z equals array nuclear 10, is an expression assigning to a proxy called Z, a new array, a new ordered list of 10 elements. Now, if you evaluate this line, you will see something happening to the post window. Maybe you can't see it clearly, so we clear the post window and evaluate it again. And you see that you have an object which is enclosed between two square brackets, and it's filled with nil. Now, nil is a special element in the SuperCollider language, representing the idea of nothing. So a nothing object. Nil is, by the way, a reserved word. So in fact, you have seen that not all the elements in the language are shown in black, rather some are shown in various colors. I have a specific colorization, so maybe this is not the colorization that will appear on your screen, but that's not relevant. The point is to have different color. Different colors do not have a specific syntactic value, but they are a feature of the editor to help you understand the organization of your code. So you see that this is blue and this is in purple. And by the way, as you can see, the post window is posting in green. Now back to nil. If you write nil, you will see that it will get a specific color because this word is a so-called reserved word. So it has a specific value. There is a set of specific reserved words in the language that have fixed meaning, and nil represent the notion of nothing. And by the way, if you write it in Latin style, real Latin style, nihil, you will see that it is not purple anymore because it is not the reserved word. So we have created an object Z, and Z is an object that is available for us to work with. We have an empty object, so we have a sort of empty sequence that we can use, let's say, filling it with various kind of elements. Now, what is interesting here is that in order to create a new object, we had to use a specific construct. And in particular, as you can see, array here is written with capitalized letters, and in fact, because of this, it is colored in blue. Now, what happens here is that array is a class. What is a class? In a very Aristotelian way, all objects in our universe, the universe of the SuperCollider language, all objects belong to a certain class. So the universe is organized into classes of objects. So back to our idea of the class, meaning teaching class. There are many computers, there are many chairs, there are many desks, there are many students. All these objects, all the, let's say, students, belong to the same class. A class that in a let's say, pseudocode style, we could call student. So the point is that, do we want to create a new student? Well, we could say something like this. Let's say age will be the name of a new student. So what happened here? You see here an example of an instantiation of an object, which is exactly like this, apart from the fact that this is a fake example. The point is this one: in order to use object, we have to create object. We do not create object, let's say, from scratch, or better, we create them from scratch, but starting from a set of templates, which are the classes. So the language gives us a large bunch of classes, and starting from these classes, we have the possibility. Now I am exactly in the middle of this slide, so I can try to move a little bit, maybe, but then the sun is moving. Okay, so the point is that starting from a set of classes that, let's say, metaphysically represent all the possible entities in our universe, we can create concrete examples, call them instance of these classes. So it's just like philosophically, we have a notion of, let's say, studentness, represented by the class student, and starting from the class, we create a single student. Name it H. It's not such a beautiful name, but it's a possible name. And H now is a student. Puff, and we have a student. And we can make him do various things, like follow the lesson, prepare for the exam, write code in SuperCollider. Okay? So, in object-oriented programming, the idea is that the universe is made up of classes. All the objects that are concrete comes from these abstract classes, and the set of classes is a sort of possible explanation of the ontology of this universe. So it's just like classes represent the ontological organization of the universe, the set of possible beings in a very abstract way, and pragmatically starting from the classes, we create concrete objects. What is the difference between a class and an object? Well, let's consider another fake examples like these. Now, what are we doing here? Well, actually here, as our student named H felt a little bit alone, then we decide to give him a companion. And K now is a new student. So now we have a population of two concrete students named H, the two twins H and K. H and K are our two students, two instances of the same class. Now, what is the meaning of this organization in classes? Well, the point is that a class is a good way to organize a set of features. There's no way I can cope with this slide. No, I can do this, but I'm getting too far. Maybe in this way, maybe in this way. No, maybe maybe I can do something like this. That would be better. So there is no way to cope with this slide. No. Okay, back. So the point is that a class is a good way to organize the information and fact. Let's start from concrete. Why do we call all these people in a certain class, teaching class, students? Because they are, well, of course, they are different human beings with different tastes, from music to food to politics and religion, but they have something in common because they are all attending the same class. It is assumed that they have all to study the same course, and we are expecting that they behave at least in a certain way. We are not interested in the way in which they are dressed, but we are interested in the fact that they probably have to show up at lesson, and they will have to maybe take notes, they will have to show up at the exam, and they will try all to pass the exam. So a certain number of features characterize all the students, and it makes sense to group them into the class students. So if you are a student, it is supposed that you go to lesson, that you try to pass, that you study, you try to pass exam, and so on. In short, the idea of classes is exactly the point of organizing information in an efficient way by organizing certain types of features and capabilities into under the same concept. So Z is an array. Fine. Z is an array, and what can we do with array? Well, as an example, we can say something like this. Now, what is interesting here is that we are addressing the object. So the point is that in object-oriented paradigm, we're still behaving in a very imperative way. So we are not addressing an abstract computational agent. We are addressing object. Still, we are giving these objects orders. How do we write this order? Well, there is a very general syntax, which is, by the way, it uses substantially mostly the same convention in all so-called OOP languages, object-oriented paradigm languages, that is written in this way: the object, a dot, and this, which is a message that we are sending to the object. So z.class is a message that we are sending to z. What is z? Z, as we saw, is a concrete instance of array. Is there a way in which we can translate this formal syntax in a more, let's say, plain English construct? Yes, you can think in this way. So substantially, you can translate these as these. It means that when you have a syntax like this, you can always read it like a vocative A, Z. You can translate this as a comma, and you can translate this as a message you are sending to the object. So AZ, please, if you want, tell me your class. In fact, what happens if you evaluate these is that you get on the post window, array, meaning that Z is giving you back, the technical verb is returning, Z is returning the class. And we know that this is the class because we created our Z from as an array, so Z class should give us back array. So main point is that first we create object from a fixed but very large set of classes, and all these classes represent altogether the ontology of the domain we are working with. And then, once we have objects, we can address this object, giving them order by means of this kind of syntax, which is typical of object-oriented computer languages. So, Z class gives you back, returns an array. But what happens here? If you look back here, you can see that there's no way to cope with this light. Maybe in this way? No. Maybe in this way. I can do this. Maybe it's better. Maybe it's better. I'm sorry. So if you, well, not so much. If you are, if you're looking to the first expression we wrote, meaning Z equals array nuclear, etc., you can see that in this case, there's something different from what we discussed here. So here we are dealing, what are we doing here? Is that we are properly sending a message to a class. But shouldn't we send messages to concrete objects? Well, you can send messages both to concrete objects, meaning instances of a certain class, like Z, or in our in our fake example H or K, or directly to the class. What is the point in sending a message to a class? Well, the first, there can be many possibilities, of course, but surely one that we have to take into account is that when we start, we do not have objects, we only have classes. So the point is that at least we need to create objects, and in order to create object, we need to send a message to a class saying, hey class array, please create a new array. So the message here, in this case it is nuclear, typically it is new, it is the so-called constructor method, meaning that it is a command that we always send to classes to create new instances of the classes. So when we start, we do not have instances. At least in that case, we surely have to address directly the class and saying, hey, class, please give me back, create for me a certain instance. Then we can work directly with our objects. So once we have the students H and K, then we can deal directly with the two students. As you can see here, you have nuclear, here you have new. Both cases, both are examples of constructor methods, meaning instructions to create new object. That can be many. There can be many objects, many methods creating objects for you. Array is a good case for this, because let's consider that we have, let's call it Z again. So now we in a certain way we destroy Z, because we write it over, meaning that now this name is dedicated to a new instance. Let's look at this. And in particular, let's do this. So, what is happening here? Well, now Z is a new instance of array, and you might say, but I can't see any new here. Yes, because what is relevant in a constructor method is not to have a new prefix, but to create a new object. Series is a constructor method that gives you back a sequence of numbers, and in particular here we specify that there should be 10 numbers. So this is a constructor method creating an array, a new array with number from 0 up to 9. So this is a constructor method. And there are many possibilities, there are many constructor methods that can be used to create, customly, to tailor the way in which you want your object to appear. A term that I have used but I have not introduced is method. So the point is the following. Let's try to focus better on this point. So if you look at this image here, you can see that this block represent a possible object, and this is a concrete object, and what we are doing in object-oriented languages is that we have a certain object which is given certain properties called attributes, and is given certain capabilities called methods. And so what we do is that we send messages to this object. When we send a message to a certain object, this object becomes the receiver of this message and tries to reply to our request by looking at its methods and find a method that matches the one we request. So let's suppose that we have a hippopotamus. We are like small goats working with animals, and we create an hippopotamus. Now this hippopotamus has certain attributes, meaning certain properties, like having a certain weight or having a certain color. And surely it has some capabilities. It can run better, it can surely swim. Hippopotamus are very good swimmers. So, well, surely our hippopotamus cannot fly. So there will not be a method called fly in our hippopotamus. It will not be listed among its capabilities, and it will not have the properties of having wings. Evidently, it's an hippopotamus. So once we have our hippopotamus, what can we do? Well, we can send messages to the hippopotamus, and a message that we can send is hey hippo, run. So suppose we have something like this. H is an hippo new, and of course I have erroneously evaluated the the expression, so there's an issue here because class not defined. There is not a class hippo in SuperCollider, of course, but let's suppose that I have a class hippo. Now H is the name of our hippo, and the name of our hippo, H. So once we know that its name is H, we can say hey H, run. And what will happen is that provided that there is a run method implemented for Hippo, then the message run will work. So actually in object oriented languages, we have classes, which are sort of templates for creating object. We have object. All these objects are given a certain number of capabilities, their attributes, and call it attributes. Like this, attributes, and they are given also a certain number of capabilities, their methods. And so what we do is to send to a certain object a message, making this object the receiver of the message. And once the object is the receiver of the message, well, it can reply by looking to a specific method that we have invoked and say, okay, I've got it, and I will run this method. In our case, if it's run or if it's swim, our Hippo will start swimming. That is, it will start execute the code related to the swimming method. So what we do is create objects, send messages to objects. Of course, one can say, but if suppose I have an idea of a certain object that it is not included into the available objects of SuperCollider, what can I do? Am I limited in my expressive capabilities? Well, yes and no, because yes, it's not in the default class system, but the default class system is huge. But you can create your own classes. So you can, let's say, you can provide new classes to the SuperCollider universe, to your own installation of SuperCollider universe. It's not difficult. We will not address this kind of issue, but it's not particularly difficult. I have my set of classes in SuperCollider. Now, let's go back to arrays, and maybe I can move my face in another place like this, maybe. Unluckily, this does not modify the lights. So let's start with some real example, like Z is an array series, meaning that we are sending the message series to the class array, and we get back an instance of array, and we say that our array has a specific name, which is Z. Z is a proxy, is a container for this object. From our point of view, is the name of the object. So the way in which we can send our messages. We say that we need a vocative and an imperative, so we need at least a vocative. We cannot say, hey, you, by pointing. We need a name, and Z is the name we have chosen for our array. So what happens here is that this message can have some specific parameters. So let's say we want to create an our Hippo. Well, maybe we can define its weight. Will it be 150 kilos or will it be 250? And at the same time, let's suppose we want to ask our Hippo to run. Well, maybe we can specify, or to swim, better. We can specify a speed at which our Hippo has to swim. So we can pass parameters together with the message. Now, these parameters are called arguments in SuperCollider. As an example, here you see size. You see that there is the so-called autocompletion. So there are three possible parameters in creating a series of number. size, start and step. Size is the number of elements we want in our array. Let's say 10. Start is where do we want to start? Suppose we want to start from 3, and step is how much do we want to increase at each value. So here you see that we have on the post window we have a sequence of 10 elements starting from 3 with a step which is 2, and in fact we have 3, 5, 7, 9, 11, 13 and so on. So we are passing arguments. We're passing arguments to our message. Now we have Z, and what can we do with Z? Well, of course, if you evaluate Z, you get the array back. You see it is posted on the window. So as an example, we can do this. How do you read this? Well, you have to remember that it is like vocative imperative. So AZ, reverse yourself. Most of the operation most of the methods have how can I say, meaningful names, of course. So reverse is doing exactly what you're thinking at. It is reversing the array. So as you can see, the evaluation of this expression returns to us an array made up of the same elements, but starting from the last to the first, 21, 19, 17, 15, 13, and so on, down to 3. And you can do something like this. Z, mirror yourself. Now what happens with mirroring? As you can see, we have now an array which is doubling its length. In particular, you see 3, 5, 7 up to 21, which was the end of our first array, and then it is mirrored on the other side. So we have 21, 19, 17, and so on. So 21 acts like a pivot on which the reverse mechanism is mirrored back. And by the way, you can have a lot of possibilities in working with arrays like this. Mirror 2. You see, isn't this the same thing as before? No, because as you can see, 21 here, 21 is used as a pivot, but it is duplicated too. So you have 21, 21. So it's just like you take the array, reverse it, and copy. Now, array is a very important class because it gives you a lot of possibilities in relation to data organization, and this kind of organization is very important for audio and music. We say that a melody at the end is a sequence, is an ordered sequence of pitches, and the rhythm is an ordered sequence of durations or attack points. So there are many possibilities of transforming these data structure. An array is a data structures containing elements, and if you have an idea concerning a certain transformation, and it is probably implemented into the array class. In particular, if you want to see all the possibilities, and this is interesting for our introduction here, most of the operation for array are not implemented into the array class. So you will not find them in the array help file. Now, how do you access the array help file? Well, it's pretty easy. You select it and you go to help, and you should look up documentation for cursor, and you have to remember Control D in my case. I think also it's Apple D on macOS X. So once you do Apple D, what happens is that you get the documentation for array. Pretty easy. So all the classes are documented, and you can always select something and press Control D. I am selecting reverse, pressing Control D, and you get a list of all classes implementing the reverse method. So you have to find what you're looking for. You see here that you have array, but you can see here that you have arrayed collection. What is arrayed collection? Well, it is interesting because arrayed collection is a superclass. What is a superclass? Well, actually, the point is this one. Suppose you have your hippopotamus and you are describing all the feature of this animal. There are many. And as an example, you want to add to its methods the possibility of I don't know the name. Well, let's say provide milk. I don't know if it's milk because milking. Provide milk to, or let's say breastfeed its children. And so it's okay because it's a mammal. Breastfeeding. Then you understand that during the creation of all your spatial zoo, you move to apes, and then you move to cheetah, and then you move to humans, and you realize that all these animals they all can breastfeed their children. So you find yourself in the situation of describing these aspects in all these classes. Well, this is a waste of time, first of all. It's a waste of memory, because all this information must be put somewhere in your computer. And it's also a conceptual waste, because the point is that all these animals, they can breastfeed because they all share something in common. So they can all be grouped into a group, which is mammalia, the mammals. So, as they are all mammalia, what is mammalia? Well, actually, mammalia can be thought as a superclass. So, the point is that all classes are hierarchically organized into a sort of tree, and at every node you have a certain class that can have certain subclasses, so classes that depends on that class, and that class can be a subclass on its own of a certain superclass. So you have an organization that clearly resembles what is happening in animal taxonomy. An organization in the form of a tree, an organization, let's look like this one for our beloved hippo, you see. And as an example, our hippopotamus, well, it's a bit too general because you have hippopotamus amphibius, you have also hippopotamus liberiensis. It comes from the genus Hippopotamus, but then there are the Hippopotamidae that include the Hexaprotodon. But Hippopotamidae, together with Thaiasuidae and Suidae, comes from Suina, and Suina are just a subclass of Artiodactyla, including Tilopoda and Ruminantia in general. And Artiodactyla and Perissodactyla are both subclasses of Ungulata, and so on up to Mammalia. So, classes in an object-oriented language are exactly organized in this way. The interesting point here is that this is a way in computer programs, in computer science, to organize information. Because at this point here, Hippopotamus amphibius, you are only describing features that are exclusive for Hippopotamus amphibius. But if you have certain features that are shared among various classes, well, at that point, you describe them once in the superclass. And if you look at the superclass and you see the same point, so that there are features that are shared among various superclasses, then they are all subclasses of a certain superclass. So the organization in form of a tree is basic aspects of object-oriented languages. Now, back here, you can see that there is array, and I said many times if you are trying to find a certain method, you will not find it into the array help file. Why? Because many times these very general methods are described into the super class help file, and the super class help file of array is arrayed collection. And in fact, arrayed collection is a so-called abstract class. You will never use directly arrayed collection, but arrayed collection is a sort of container of information for various classes that you might want to use directly. So it's an abstract class, if you want. And its subfile contains a lot of information that applies to array. Now, what's going on here? I say that this idea is an efficient idea to organize information. Why? Well, because of course, if hippopotamus and hexaprotodon, they are all subclasses of Hippopotamidae, this means that they technically inherit all the methods and attributes defined for Hippopotamidae. So inheritance is a very important concept, and it describes the fact that certain features are defined at a certain level, the level of a certain class, and then inherited to all subclasses. So it's an interesting way of working, because you have an organized way of thinking about your universe. You have classes, but all these classes, they have certain aspects in common. So they can be organized into superclasses. So it's an efficient way of thinking the way in which the world is organized. So suppose we have array, and this is a class. It starts with a capital letter. If it starts with something starts with a capital letter, it's a class. Now, in fact, you can see that if I write it with lower letter and I evaluate this, I get an error saying that the variable array is not defined. On the other case, if I evaluate this with a capital letter, all fine. It is something that it is recognized by the interpreter. So I say that we can send construction messages to a class, but we can also send other messages. As an example, we can ask the class, the superclass of a certain class. And in fact, we say, hey, class array, please tell me your superclass. It's a polite request, and in fact, the interpreter asks back, returns arrayed collection. But we are curious and we want to know what happens here. Hey, arrayed collection, can you please tell me what is your superclass? And we got sequenceable collection. Now, of course, maybe curiosity killed the cat, but who cares? And we see that collection is up to sequenceable collection. So, collection, what's your father? Who's your father? I am your father, Luke. Who's your father? His object. So, up, 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 one step, one step, one step, and we reach the top objects. The top objects, the top class is object. So, all the classes, they all inherit from a very general single class, which is called object. Object is the most generic type of thing. So all classes come from object, and all the instances of these classes inherit some features coming directly from their very distant parent object. Which kind of features? Well, some features concerning archivation. archiving, reading, and or posting on the screen. So these very general aspects that are related to all possible objects in our specific world are inherited from object. So of course, I don't know if I have an easily all classes. So this strange object you can see here is, let's try to decrease its dimension. This is the organization plotted automatically of all the classes on my installation of some years ago. Now you probably were expecting a tree, but this is a tree actually. It is plotted radially, but it is a tree. In fact, if you do this, let's try to do this, you can see that everything comes from objects. Object is the root of this tree. The tree might be plotted radially, but it's a tree. Topologically, it is a tree. And you see that you have object, then you go down to abstract function, which is a very general object too. The notion of function we'll discuss in the next video. It's very, very important. Here you have collection. You can see collection. Let's see. You see here we have, collection, and then you have sequenceable collection, arrayed collection, array, and so on. So all this block is related to data structures. Then here you have, we say, abstract function, and here down you have Eugen. Eugen means unit generator, and it is a class representing a basic object to make sound. We will discuss this later. And being a basic object, of course, it is very, very important. You can see how many children inherit from Eugen, and so on. Now let's consider this. This is a partial plotting of the tree coming from object, then collection, and then many other objects. What we did was to start with, I don't know if there is an array. No, there is not array here. No, probably not. Let's look at this. No, this is just for other control structure. There are some of the classes, and what we did substantially was to move back from a terminal class and move back following a possible the branching back to collection, and from collection back to object. So this is the way in which, or better, this is the way in which all the classes are organized into SuperCollider. Now, what is interesting here is that you can move yourself, you can move into this organization, you can place yourself into this organization, you can explore it, you can do it as I did by means of sending messages to classes. You can do this by the help file. So if you go here, arrayed collection, let's suppose, and then you see that it comes from sequenceable collection, and from object. And are you curious about object itself? Well, you can directly go to object, and you have the help file for object. So this tree structure is accessible through the help file. Now we could also do something like this: collection subclasses. Now we're saying we're addressing collection. Say, hey collection, class collection, please tell us all your subclasses. Now what happens here is, if you see, is that we get back all the classes. They are clearly named class, two-way identity dictionary, sequenceable collection, bag, and so on. They are all data structures. In fact, you can see set, the notion of mathematical set, unordered. It is an unordered collection of objects. You have range and so on. You have a dictionary, which is a specific way of organizing data. You have a key and a value in a dictionary. No? You find the name, and once you found the name, you get the description. So name and description are linked together. You can also appreciate the fact that what is returned here, it's an array. This is an array. You see, you have a square bracket here. So we have an array of classes. You might ask yourself, are you sure? Well, I am, but let's do this. Or better, let's do this. Let's call this C. Now we have an array of classes. And we can do, hey, C, tell me, what's your class? Array. And you get back array. Now, what I was writing here was this, because of my habit. And I do not need to assign to C. I'm just interested into the information. If you evaluate this, you get array. What is happening here? Because we have said that typically what happened is that we send messages to object and also to classes, and then we have something back. And how is it possible to have these two? Well, actually, this is called message chaining, and it is very interesting, very powerful, and sometimes very confusing. So what happened here is that every time we send a message, we get something back. And depending on what we have back, which is a specific object, we can send to this object some messages. So, C, give me, assign to C what is returned to the message subclasses to collection. Okay? And then we say, okay, C, tell me, what's your class? What happens here is that we have something back here. And on this something, we can call directly class. Message chaining. It's like adding a comma, like having hippo, run, comma, swim, comma, heat. So what happened here is that we have a certain object returned here, and we directly send the message class to this object, and we have the same thing. We have back the same thing as here. Message chaining can be very powerful and very confusing. We will not use it too much, but sometimes can be very interesting, and I'll immediately giving you an example. So let's suppose you have this. Then now we are fascinated by message chaining, and we say reverse mirror. So if we have reverse, we have this, and the point is that once we have this reverted, we can mirror it. Reverse, then mirror. What is returned here is the reversed version of Z, and we mirror it. And so, of course, you see that Z is this one. This is the reversed version plus its mirroring. Now, it might happen that if you do something like this, you get a little bit crazy understanding what is going on in this chained processing. So what can you do? Maybe you get some mistakes. How do you debug? That is, how do you find mistakes in SuperCollider? Well, actually, the point is that you have a certain computation. At a certain moment, you have mistakes. And the point is that you want to know at which point these mistakes happen. The only source of information is the post window. So the point is to try to write on the post window some relevant information. As an example, we have a method which is called post and post line, like this. Post line means gives a textual representation on the post window of the returned object. Post ln means post line and means that then it will keep on posting on the next line, which is quite useful. Otherwise you get all the message, all the posted messages that are chained together. So if you do something like this, you see that this is what is posted by post line, and if you add another one, you can keep inspecting what is going on, one operation after the other, like this. So you see that the reverse give us this, the mirror give us this, and finally we do not have to ask again post line because we have mirror too. So the point is that a certain representation of the object is always posted at the end, so we see what happens with mirror too. But if we want, we can also do this and this. Now you see that Z post line means, hey Z, post a representation of yourself, then reverse, then post a representation of yourself, then mirror, then post a representation of yourself, then mirror to, and post. Of course, this line is exactly like the following one, because what happened is that, as I said, there is always a sort of internal post line on the last method invocation. So here we can inspect the whole process. Now, what happens here is that what is post line doing? Actually, post line is doing something and returning the same object. So one thing is to do something like posting on the post window, but a different thing is to transform the object, that is to return the object. So the point is that we can say that post line is transparent, meaning that it does not affect computation, so you can place it anywhere. It's just a way in which you can post this information on the post window, but there will be no interference on the process. So it's just like a transparent way. So our chaining is unaffected in terms of computation by inserting post line, but it gives us information by means of printing on the screen. Post is like print in most programming languages. Here we use, in SuperCollider, we use post. So as an example of, let's see, as an example of message chaining, you can see here what is going on. So you have here an array like 1, 2, 3, 7, 5 reverse, and you get it, what is returned is this one, and you can ask reverse again, and you have the original sequence. So this could be written like this. You evaluate this, and of course you get the original sequence, but two operations are given by means of a message chaining. Now you can do something like black magic or voodoo. Let's follow the diagram here. You have a certain concrete array like this one, the one that we have already used, and we call class. What is returned by class? Hey, tell me your class. A class. So this is a class, and we can send a message to this class. Hey, tell me what's your superclass, and we get back a red collection. And then we can call, hey, a red collection, tell me, give me back all your subclasses, and this will return an array of subclasses. Then we access the second element, which is this one. You might say, but this is the third. I will speak about this right now. So it is array, and we can call on array nuclear 3. Sorry, an interference from Italian. So let's try to implement this. So we have this, and we say that we can have class. What's going on here? That we have back array. Then let's do chaining superclass, and we have array collection. Fine. Then we do subclasses, and it's different because evidently the implementation has changed from my book, which is some years ago, and we have 2 classes now. So we have an array here posted back. Do you want to inspect everything? You can. Let's do this. Post line, not post line. Post line. Let's inspect this. Too many dots. So this is a single expression. You see 1, 2, 3, 7, 5 array here. Superclass, array collection, subclasses, and we have an array. So suppose we have an array. How do we access a certain element of the array? Because one thing is to have an ordered list of elements, but we want to access to these elements. So the idea is that we put all these objects into a data structure, but we want to have them back. So we can do something like this. I'm using number because it's easy. And the very easy way, well, this is the classic object-oriented parlance, like this. So at object at give me the element placed at this index. You know that in computer programs we count starting from 0. So 0 is 1, the first. And if you go on like this, you see that the at index 1, meaning the second element, is 3, and 3 will be the last of our objects because it's the 4th position, so it's 6. Now, while this is easily understandable, the typical way to do this is by means of this. You can say to yourself, this is confusing because I have just learned that I need to send an object a certain message by means of the dot. Yes, this is just, it's confusing, but this is so common in programming languages that, okay, better in this way. So this is the normal way. And you have just to remember that heading this means to be able to access to the position indexed 3, meaning the 4th position of your array, and you get 6. So back to our example here. We want to access this one. In this case, is the 3rd element, 2. But we know that we have only 2 classes we discovered. So we want to access to the 2nd position, 1. And now we have array. It keeps on returning things. So computation is chained. And let's implement this, nuclear 3. So now we have a class. What can we do to a class? Well, we can we can create a new empty container of 3 position, and we are exactly getting back what is depicted into this sequence here. So this is all for object-oriented programming. Then we will see examples. So the point is, when we are using object-oriented programming, the idea is that we are dealing with objects. So the world we are controlling, we're trying to control, is made up of objects. Now these objects are, each one of them belongs to a specific class, which is a sort of abstract identity, and that provides certain properties and capabilities to all its instances. These properties in OOP jargon are called attributes, while these capabilities are called methods. All the classes, on their side, they are organized into a tree of classes. The idea of the tree, of this hierarchical organization, is useful because it gives a possibility to structure the information, so to organize it in an efficient ways, so putting together things that share some features. Now, if this is a tree, this progressive hierarchy must have an hand, and this end, the root, the so-called root of the tree, in SuperCollider is a very general abstract class which is called object. All classes comes down from object. So you have to explore the classes that are available. You can do this by means of the help files. Of course, we will see some of those classes in the next videos. And what you can do when you program is, given a certain set of classes, to create various instances of these classes, and you can send messages both to classes. We saw some possibilities like creating a new object. It is a very basic one, but also asking for some internal organization of the class tree, no? Some messages dealing with this aspect. And you can send messages to concrete objects once you have created them, in order to make them perform certain computations. How do you send this message? The typical structure is the name you are addressing, be it a class name or a certain name of an instance, dot the method you are willing to use. And you can think about this in terms of vocative, hey you, imperative, do something. You can add to this message some parameters. They are called arguments, like we saw in series. The help files provide a list not only of classes, but for each class a list of methods and a list of arguments for these methods, with an explanation, with and by the way, many times these arguments have default values. So the organization of a program is creating objects, substantially creating objects, and making these objects interact. Last things we saw is message chaining. Message chaining is interesting because it explicitly refers to the idea that each time we send a message, the object being the receiver of the message, the object reply by invoking a certain method, and this method, this computation, returns, that is, it sends back a certain object on which we can call again, we can send again a certain message. So as you can see, once you're into this, you can see that the interface, in a very abstract way, the way of thinking is always the same: sending message, having something back, sending messages, having something back. And of course, when you write a program, you want to do something, so it means you want to have a certain computation working to create sound, to create certain sound organization. So the point is that you keep on working in this way, by creating objects, sending objects, and so on. So the assignment is to think about this, to work with arrays, to explore the help file, and then we'll keep on working on the language, because the language is the key to control the server. And the server makes sound, so as you might see, might think, the point is that control is the real crucial pivot in things, not to make sound, but to control the things that we are doing with sound. And the language is the interface that we have to control all the sound and music in general processes.